Okay, so just to recap, this is what the graph would look like if you were graphing the contingency table. It's a typical graph to make when you're looking at two variables, two categorical variables. This is the distribution of party registration. It's a conditional distribution. Why? Because it's for just one condition of another variable, in this case the gender variable, and the condition is female. And then here's another conditional distribution of party registration, and the condition is male. Whenever you're assessing independence between two categorical variables, you need to look at the conditional distributions, usually in relative frequency terms, because many times your groups are not the same size. Independence, remember, is the opposite of association. Association is synonymous with relationship. So this is actually what's going on, and just say it out loud. Based on this, are these variables independent? No. There's differences in the conditional distribution, so hopefully you get that by now. What they want from us in part C is what would this graph look like if there was perfect independence, meaning gender has nothing to do with party registration. And just to clear up a misconception that I saw in other periods, it doesn't mean that there has to be an equal distribution or an even distribution. For example, in this case, it doesn't mean that you have to have 1/3 in party W, 1/3 in party X, and 1/3 in party Y. No. It just means that for males and females, the rates have to be equivalent for each party. Okay? The challenge is how do we figure out what the rate is for each party? For this one, I'll go to a volunteer. Yeah.
So to determine what is equivalent to males and females, I believe you would simply look at the percentage of males that that's with one party, say party W, and then the percentage of females that take the same party, party W in this case, and find the middle.
So I'm going to stop you there, because that's not going to work, because there's a different number in each. And I wouldn't even do that. It's not necessary. So let's see what some other people have to say.
I just added up the totals for females registered for the party and males registered for that party, and then put that sum over the total number of males and females was 15.
Okay, I'm not sure if that works, and it's also unnecessary. You don't have to regard females and males here. You can just look at the overalls. Okay, so I just misunderstood you. So 88 divided by 500 gives you the overall registration rate for party W. (17.6%). If gender has nothing to do with party registration here, I expect 17.6% of females to be in party W and 17.6% of males. Capiche? Make sense? Okay. I don't know what you're thinking, but I will move on. So now for our graph, for party W, we're going to go to 17.6% or 0.176. And because we're assuming independence here, it must be the same across categories. Next up, we look at how many are affiliated or registered with party X, 244 out of 500. 48.8%. If you want to know where to go on the graph for that, you can add that to 0.176. So we want to go to 0.664 on the x-axis. It does not matter what order you put them in.
Please excuse this interruption. Route Sabrina Beckham, please call the attendance office at extension 6625.
And lastly, for party Y, I don't even need to do a calculation in terms of how many out of how many, I can just do 1 minus 0.664, so 0.336. And then we want to tell the reader how we're getting these things. So down here I would write some sentences about how these numbers were obtained and why they're valid. Okay? Any questions on part C? Remember, this is all public information on the College Board website. Questions, scoring guidelines, student samples. So feel free to take advantage of that.